Very good afternoon. Myself Dr. Ruchi Gupta, Associate Professor IT Department. Today we will discuss the concept of coupling and cohesion. As I have already discussed concept of software designing in my previous lecture. So coupling and cohesion, it is basically one of the dependency feature between the modules or within the modules. So we have to discuss this dependency in detail in this lecture. So what is coupling? Coupling is a measure of degree of interdependence between two modules. So for example, this is module A, this is module B, and suppose if module B access some data from module A, and if module A want to access some data from module B, it means we can say that there is a dependency between module A and B. Or if A pass some parameter to B, or if B pass some parameter into A, so we can say that there is a dependency between the modules. So coupling is a measure of relative interconnection among the modules. So we can say that there is some interconnection between two modules. So this is coupling, means any data item or any function or any content is to be passed from one module to another module. It is called dependency between two modules, or it is called coupling. So coupling is also two types. One is a high coupling and another one is a low coupling. So high coupling, one is a coupling is high. When coupling is high between the component, when if one module is to be heavily dependent on another module. So this is high coupling. It means if we have to use, we have to pass all the content from one module to another module. So they are heavily dependent on each other. This is called high coupling. So that is, there is a lot of communication between them. As I have told you that if content of module A is transferred, the whole content is to be transferred into another module, then it is highly coupled. And second one, it is a low coupling if the dependency is very few between the component. For example, if we have to just pass one or two parameter from one module to another module, so it is very low dependency. So we always consider in mind that at the time of designing, we have to consider the loose coupling and we always avoid the high coupling. So the coupling should be minimum. This is one of the major factor of the software designing, that coupling should be minimum between two different modules. So loose coupling, it promotes the maintainability and adaptability, since changes in one component are less likely to be affect to another. It means if we have to change in one module, then there will be a chance to minimal change in the another module. So this is higher the coupling, higher of the dependency, and minimum the coupling is minimum the dependency. So basically this is loose coupling, this is high coupling. Here the modules are to be loosely coupled and they pass minimum data items from one module to another. And in this dependency or highly coupled, each and every module is to be passed the whole data content to another module. And this is a no dependency or uncoupled. It means all the modules are independent, no one is interact with another, no one will pass the data item or function or content from one module to another. So this is uncoupling or uncoupled. But this situation is not applicable for the software development, because in software the dependency it will remain at the time of designing, because all modules are to be dependent with each other. So without dependency, we never develop any software. So, but we have to consider the low dependency. So these are the types of dependency: data, stamp, control, common, and content. This is a type of loose coupling, and this is a high coupling. So at the time of designing, we have to consider that we have to follow the loose coupling instead of high coupling, because it is a tight or high coupling. In this, more dependency, more coordination, more information flow from one module to another. Or in this loose coupling, less interdependency, less coordination, or less information flow. So first of all, we have to know that what are the various types of coupling. So the first one is a data coupling. So what is data coupling? Two modules are data coupled if they communicate through a parameter only. It means if we have to pass one parameter, for example, if we have to pass a customer ID from one module to another, and another module, suppose module A pass the customer ID to module B, and customer B, it access the whole information using a single parameter, that is cust ID. So this is a data coupling. So two modules are data coupled if they communicate through a parameter. So data couple exists the property that all the parameters to modules are either simple data type, or in the case of record is being passed as a form of parameter, and all the data members record are used and required by the module. So example of this type of data type of coupling is, for example, we have to pass such parameters between the two modules, for example, integer, floor, or character. So this is a minimal dependency. We have just passed data parameters from one module to another module. So this is an example. This is an example of data coupled that is illustrated in these two modules, which retrieve customer address using customer ID. So this module B, suppose this is module A, this is module B. So module B retrieve the customer address. It retrieve the customer address only by using the customer ID from module A. So we have just passed the one parameter, that is ID, and we have just retrieved access the customer address for the customer of the customer. This is data coupled. So coupling a module C only the data items. We have just passed the data items if it is required. It is the best form of coupling. But the weakness of this data coupling is that a module can be difficult to maintain if many data items are to be passed. So if we have to pass more than elements, then it will be difficult to maintain, because two parameters can also independence that a poorly partitions approach. Now the second category, it is a stamp coupling. So stamp coupling occurs between two different modules when the data are passed by the parameter using a complete data structure. So instead of passing one or two parameter, we have just passed the whole data structure from one module to another module. This is a strong form of coupling as compared to the data coupling. So in this coupling modules, the data are passed by the parameters using data structure that contains a field which may or may not be used. Because we have to pass the whole data structure, if one field is used or not, we are not bothered about that. So it occurs when too much information is passed to a function. At that time only we have to use such type of coupling. So stamp coupling occurs between module A and B. A complete data structure is to be passed. For example, this is an example of stamp coupling. A module that retrieves customer address using only customer ID is extracted from a parameter need customer details. So in this case, we just want to access the customer address, but instead of passing only one parameter, that is customer ID, we have just passed the whole data structure, the whole customer details from module A to module B. So as a rule of thumb, never pass a data structure containing many fields to a module that only needs a few. So we have just used this stamp coupling when there is a need of whole data structure. The strength of step coupling, it is a loose form of coupling. It simplifies the interface between the module. And the weaknesses are, it promotes the creation of artificial data structure. Means we have to just create a duplicate data structure into another module. Still we have required or not. Although this bundling is meant to reduce the coupling between the modules. Now the third is a control coupling. A module A and B are said to be control coupled if they communicate by using a control information. For example, if we have to pass the flag from one module to another, we have to pass the flag information and we have to set the flag value 1 or 0. So, an example of this control coupling is a flag set in module and tested into another module. So, by mean of flag that are set by one module and it reacted upon the dependent module. So, this is a flag, we have to pass the flag from one module to another. So, module 2 is only execute once the flag value will be 1, which is passed by the module 1. So, two modules are control coupled if they using at least one control flag. The control flag, it is a variable that control decision in subordinate or superordinate modules. So, this is the control coupling. In this example, control couple, a module retrieve either a customer name or customer address depending on the value of flag. So, we have just retrieved this information on the value of flag. Next is the common coupling. This is another strong form of coupling. So, two modules are common coupled if they share the data through some global data items. It means we have to, if we have to declare some data item in one module globally, then we can use anywhere in the software, anywhere in the modules. And these modules share the common or global or file. So, modules have read-write access to global data blocks and module exchange data using global data blocks instead of argument passing. This is a strong form of coupling. So, this is an example of common coupling. These, if we have to declare these variables globally, then we can use these variables in any of the module. But if we have to change in one, then this is also necessary that anywhere in the program, if we have to use the same parameter or same variable, then we have to change that location also. And this is the last, and a content coupling. It is a strong form of coupling or it is a burst coupling. In this, exists between two modules if they share the code, a branch from one module to another, or we can say that module is directly reference the content on the another module. For example, if we have to modify the P, module P modify the statement of module Q, then module P refers to the data of module Q. So, as I have seen all type of coupling, content is the worst coupling and data is a best coupling. Now, we can show at the time of designing that how the modules are to be coupled with each other. This is one of the example of coupling. So, we have to write in the tabular form dependency between two different modules. We have to show here. Coupling can be achieved through parameter passed among the modules, and we have to avoid the passing some undesired data to calling modules. Now, we come on the next dependency, that is called cohesion. And cohesion is a measure of internal relatedness of the components of the module. It is also a dependency, but it is a dependency within the module. So, it should be minimum, and we have to consider that it should be minimum when we have to design any software. So, cohesion is the measure of degree to which elements of modules are functionally related with each other. So, these are the types of cohesion. Similarly, like as coupling types, coincidental, logical, temporal, procedural, communicational, functional and informational. So this is highly cohesion, this is the best cohesion, and this is low cohesion or worst cohesion. So these are the examples of cohesion. So first is the informational cohesion. So in informational cohesion, a module performing a number of operations, each with a unique entry point and independent code, and all the operations are performed on the same data. It means when we have to perform all the operations on the same data, so this is informational couple. It means each function in a module must perform exactly one action. So there is no need of write the same function again and again, because we have to use the same function. This is informational cohesion. Second is the functional cohesion. So it is exist if different elements of a module cooperate to achieve a single function. So for every essential element to a single computation, it is contained in the component, and every element in the component, it is essential for the computation. This is a functional cohesion, as we have seen in this example. Function part A, part 2, part 3. This is functional cohesion. Now we come on the sequential cohesion. So what is sequential cohesion? When module A output some data items which become the input for module B. Module A outputs some data items which form the input to B, and this is the reason for then we contain the same procedure. So data flow part, it differently procedural cohesion in the functional programming language, as we have seen here. This is a sequential. Function B is execute, the output of one is input to another. The output of B, it becomes the input for C function. So this is sequential. Now communicational cohesion. A module is said to be communicational cohesion if all the modules refer or update the same data structure. For example, update the records in the database and we have to send it for the printing. Update a record on the database, then we have to update the record on the database and same record will be printed. So this is a communicational, means all are linked with each other. This is a communicational. Function A, function B and function C all are using the same, all the functions using the same data items which is stored globally. This is communicational. Now the next one is the procedural cohesion. It is a form of cohesion obtained when software components are grouped in a module to perform a series of functions. Means all the functions are to be executed serially. For example, write output record, read, pad, return. This is procedural. As we have seen in this example, what is procedural? This is procedural. Function A, function B, function C, and all the functions are to be executed sequentially, related by the order of function. All the functions are related with each other. This is procedural. Now we come on temporal cohesion. So a module contain a function that are related by the fact that all the functions must be executed in the same time span. Suppose if all the functions are to be executed in the same time span, then it is a temporal cohesion. For example, notifying the user, lots of different activities occurs at the same time. So this is an example of temporal, related by the time t0 plus x, t0 plus 2x. This is a temporal cohesion. Now, logical cohesion. A module is said to be logically cohesive if all the elements of the module perform the similar operation, like error handling, data input, data output, An example of logical cohesion is a case where a set of print functions gather the different output reports that are arranged into a single module. So, elements of components are related logically, not functionally. Means they are related with each other, but they are logically related each other. They are not functionally, the function is not same, but they have to perform a similar type of function. They are logically related with each other. This is logical cohesion. And next is the coincidental cohesion. In this exists in the modules that contain instructions that have little or no relationship with another function. So, in this coincidental cohesion, all the functions are distinct with each other and there is no logically or functionally correlated with each other. Or we can say that all the functions are unrelated with each other. So, such type of cohesion is called coincidental. So, coincidental is the worst case and informational is the best case of the cohesion. So, this is the dependency. Coincidental is the worst case and functional is the best case. And this is the relationship between cohesion and coupling. If software is not properly modularized, so host of seemingly trivial enhancement or change will result into depth of the project. So, therefore, a software engineer must design the modules with the goal of cohesion, with the goal of high cohesion and low coupling. So, this is high coupling and this is a low coupling example. So, as we have seen that how we can maintain the dependency at the time of designing. So, good designing strategy is to organize the program modules in such a way that are easy to develop and easy to change. And structured design techniques help developers to deal with the size and complexity of the program, and designer create the instruction for the developers at how code should be written. And at the time of designing, we have to use a 3 type of strategy or 3 type of approach: top down, bottom up and hybrid. I have discussed this approach, these approach in detail. In the top down approach, we have to start with the main module and then create the submodule, again create the submodules and submodules. So, we always start from the main modules in the top level designing, and in the bottom level designing, we always start with the submodules and then we integrate these modules and will go on to the top module. So, top level is an opposite version of bottom level design, and most of the company use this top level designing. And hybrid designing, we can say it is a combination of all these designing, top level and bottom up. So, for top down approach to be effective, some bottom up approach is essential for the following reason: to permit common submodules. It is near to bottom of the hierarchy where the intuition is very simple and need for bottom up testing. So, in the use of pre-written library modules, in particularly reuse of the modules. So, we can use both approach, top down and bottom up. We have to mix up these two approach in the hybrid method. So, this is all about the basic concept of designing. Thank you very much.